Installation or restoration of watercourse crossings must be conducted in conditions that are isolated from the stream flow in order to maintain water quality. This means that the water must flow around the worksite by using force of gravity or pumps. Common ways to divert water include cofferdams, temporary diversion channels, and pump-around systems. It's important to estimate the stream flow that will need to be managed prior to starting construction. The method chosen to dewater a site for watercourse crossing installation should consider the slope of the watercourse, height of the stream banks, water flow, existing site conditions, and the type of crossing that will be installed. Regardless of what method is chosen, all dewatering procedures should adhere to the following best management practices. Limit the amount of time the watercourse is without water. Downstream flows must be maintained at all times. Avoid working during or after large rain events. Monitor the dewatering system throughout the installation phase for erosion, sedimentation, changes in flow, and presence of fish. Barriers used to block water flow should be inspected at the start and end of each workday to ensure they are working properly. Monitor for seepage in the work area and pump out any water from the work zone. Divert pumped seepage water onto stable, non-erodible vegetated surfaces or equivalent measures to prevent downstream sedimentation. Have emergency plans in place in case of sudden high flows or breach of the isolation measures. Secondary containment systems should be in place for all equipment, such as pumps and fuel, to ensure leaks do not contaminate the watercourse. Ensure that equipment cleaning protocols are being used. Follow the Government of Alberta's decontamination protocol for watercraft and equipment. And monitor the downstream end of the diversion channel, where the water rejoins the original watercourse to ensure that erosion and sedimentation are not occurring. Types of dewatering methods. Cofferdams. Cofferdams are in-stream barriers that block the flow of water or direct the flow to the opposite side of the channel while work is being conducted. They are often used on large watercourses and can be used in conjunction with temporary diversion channels or pump-around systems. Most cofferdams are made from interlocking pieces of steel. However, they can be made from other materials such as sandbags, gravel wrapped in plastic sheeting, and inflatable aquadams. Cofferdams must be constructed and used in a way that prevents excess water seepage, handles the force of all of the water while being tall enough to prevent water from spilling over the structure, and leaves as much of the watercourse open as possible. Good practice is to leave 2/3 of the original water channel open. Channels that restrict too much water flow can risk causing unnecessary erosion. Temporary diversion channels. Temporary diversion channels are an alternate path for the water to flow freely around an isolated watercourse crossing construction area. They are often used on large watercourse crossings, where a pump-around system would not be adequate for the water flow. Temporary diversion channels run parallel to the original watercourse and can use existing site features such as ditches or culverts. When constructing a temporary diversion channel, some important considerations are to line the diversion channel with plastic and secure it in place with rocks and stakes. To divert the water flow to the temporary channel using a system such as a cofferdam. Construct the upper dam first, then the lower dam if it is required. Pump-around systems. A pump-around system, also referred to as a dam and pump, involves moving water around the worksite using pumps and hoses. This dewatering system is often used for smaller watercourses. Multiple pump systems may be required depending on the volume of water. It is important to set up the pump system before blocking off the watercourse. The next step is to create a bell hole or sump with an excavator scoop on the upstream side of the worksite, just downstream from the dam. This creates an area that the sediment-laden seepage water can flow into. The pumps can then remove the water to maintain a drier, isolated work area. Another sump should be placed just downstream of the work site within the isolated work area to manage seepage water that emerges along the isolated area. Make sure to install the pump on the side of the watercourse that is furthest away from the site access or busy area so that it is out of the way. Best management practices for pump-around systems include: place appropriate sized screens on intake hoses to prevent fish entrapment. Follow Department of Fisheries and Oceans Canada fish screen guidelines. Ensure the pump system is appropriately sized for the flow of water that is expected. Always have a backup pump system on site to deal with emergency malfunctions or high water flow. The pump system should be equipped with sediment control measures, such as discharging to a vegetated area, or the installation of a screen for sediment-laden water pumped from the isolation area. Protect the land from pump-off water discharge to eliminate erosion. Poly can work well for this. When construction is complete, continue pumping water around the site so sediments are contained by the downstream sump until the water runs clear. Remove the downstream dam first, followed by slowly removing the upstream dam to prevent a large amount of water from dislodging sediments. Pump systems are often used to remove seepage from work areas even when they are not the main dewatering system in place. Erosion control and sedimentation prevention are important aspects of water management during the watercourse construction process. Some key processes that can help ensure that practitioners are doing their due diligence in this regard include: establish material storage areas away from the in-stream area and local drainage paths. Install silt fences where the water may flow towards the flowing stream. Consider other sediment control measures, such as trap lows to help prevent downstream discharges of turbid water. Set up an equipment wash station at the entrance to the site, away from the watercourse. Controlling erosion prevents sediment from moving, and erosion control measures should always be implemented to ensure the protection of the watercourse. All erosion and sediment control practices need to be monitored and maintained over time to ensure they are functioning correctly.